Hello everyone, welcome to MEMONEET. This is Shivam. Today we'll be discussing about the part 3. Okay, so moving on to the first question. The first question is from I think electrostatics. Two spheres A and B are exactly same mass are given equal positive and negative charges respectively. Their masses after charging. Okay, so relation between mass and charge. Right? One is negatively charged, another one is positively charged. So negative charge means gain of electron plus electron. Positive charge means there is a elimination of certain amount of electron. As in the negative charge, some amount of electron is gained by the object, right, or the gained by the sphere, right. So therefore, the mass of the object will increase. In this case, the mass of the object will decrease. So therefore, I think mass of A is lesser than mass of B. Okay, because the object A is positively charged. The next question. uh, Gauss's law states that. Okay, Gauss's law. What is Gauss's law? It states that the total electric flux out of a closed surface is equal to the charge enclosed divided by the permittivity. Right? That it is this Q into 1 by epsilon naught. Right? That is equals to the flux phi. Okay. So that therefore I think option 2 is correct. Not in the open surface, the closed surface. Right? Uh, Number 3 is a air question. Moving a distance 2 times the initial distance away from the infinitely long straight uniformly charged wire, the electric field reduces to 1/3 of its initial value. Okay, seems correct. The electric field is inversely proportional to distance from an infinitely uniformly charged wire. Okay, okay, okay. Now, for an infinitely long wire, electric field is given by lambda. Uh, lambda is the current density in one dimension. Okay, lambda is lambda divided by 2 pi of r epsilon naught. Okay. On moving a distance 2 times the initial total distance, first was r, now twice the distance is moved, therefore r plus 2r it will become 3r, right? So if we put the value here, first this is the E1. If you take this is E1, then E2 will be equals to nothing but lambda divided by 2 pi, in place of r will be placing 3r. Therefore E1 by E2, okay, E1 by E2 will be equals to 3. That means E2 equals to E1 by 3. Therefore, the statement, the assertion was correct. It will become 1/3. Okay. But, and also the electric field is inversely proportional to the distance, right? E is proportional to 1 by r. Right here, E lambda divided by 2 pi r epsilon. That means E is electric field is directly inversely proportional to the inversely proportional to the distance. Right. So therefore, option assertion is correct. Also, the reason is the correct explanation of the assertion. Right. That means option 1 is correct. Okay, moving on to the next question. Question number 4. The figure shows the electric dipole placed along x-axis. As we move from point A to point B, the charge point A to point B, the potential changes form. Okay. Okay. As we move from potential A to potential B, potential A to potential B, I think. mm, mm, what will happen? If an electric dipole is placed at an arbitrary point, okay, let us take a point P. It is at an angle theta, right? If now for A is placed in this direction, the angle will be equals to 180 degree. Theta is equals to 180 degree for this, right? For angle A, right? Put the value in this formula 1 by 4 pi epsilon 3 cos theta by r square. What you will get as cos theta. cos 180 degree equals to -1, that this whole value will be negative, right? This whole value will be negative. But in case of if the for the point B here, this point, this is the B point. Here the angle theta should be taken as 0 degree, right? And cos 0 is equals to 1, positive 1. That means here the whole value will be in positive. Therefore, we can say from if the potential moves from A to B, it will be moving from negative to positive. Okay, negative to positive. That means option negative to positive. That means option 2 is correct. Now question number 5. Which one of the following figures shows the correct equipotential surface system of two positive charges? Okay. What is equipotential surface? Equipotential surface is a surface that is normal to the electric lines. Okay. The following figures, this figure, okay, this figure shows the equipotential surface along the electric field. Right. So that means option 3. You can match the figure is option 3. Hmm. Oh. When air is replaced by dielectric medium of force constant k, the maximum force of attraction between two charges separated by a distance. Okay, as we all know that if force by Coulomb's law is given one F equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. That is the force acting between two charges, right? If air is placed, if the two charges are placed in air, that means here this will be epsilon naught, right? But whenever there is an introduction of certain medium, as we all know, k is equals to epsilon by epsilon naught, where epsilon is the permittivity of a certain medium. That means epsilon will be equals to k into epsilon naught. So for f medium, it will be equals to 1 by 4 pi k epsilon naught q1 q2 by r square. So therefore f medium by f air will be equals to k, right? So the medium will be equals to f air by k. So there will be a decrease. Okay, there will be a decrease of the force between there is a decrease of force between the uh, two charges. Okay, the capacitor whose capacitance is 6 microfarad, 6 microfarad, and 3 microfarad, 663. Okay, are connected in series. Okay, it is so as we all know that 1 by C equals to 1 by C1 plus 1 by C2 plus 1 by C3 plus series connection CS, right? So if you directly put this, what you will get 1 by 6, 1 by 6, means 2 by 6 means 1 by 3 plus 1 by 3, that is equals to 2 by 3, right? This microfarad, and it is connected to a 20 volt. V is equals to 20. Find the charge on the 3 microfarad, right? C is equals to, that means 1 by CS, that means CS equals to 2 by 3, CS equals to 3 by 2, right? So the charge equals to Q into C, as we all know, Q equals to C into V, and the charge is given, I think, so C equals to 3 by 2, and the voltage is given 20, right? That means 30 microcoulomb is the charge. Okay, 30 microcoulomb is the charge. Then option number 1 is correct. Under what condition will be the strength of the current in a wire of resistance R be the same for the connection in series in parallel identical cells of each internal resistance R? Okay. Internal resistance on both the cases are good. Let first you have to calculate. So internal resistance is given. First you have to calculate, take EMF into account. Okay, EMF, the formula for E series and E parallel are given. For E series, the formula is given by N into E small, if E amount of E numbers of cells are connected in series, right? So it will be equals to NE divided by R plus NR. And for EP, it is equals to E divided by R plus R by N. It This is the formula. Okay. Now if you have, if you solve this, you will get LCM any NR plus small r, right? So if in the question it is told that it is said that uh, in a reduced distance R be the same for connection is series and in parallel for identical lenses. When if these two are now for in the question it is said that this ES and EP will be equal. So therefore I can say this one cancel out, right? R plus NR, right? That means R minus NR, that means R 1 minus N equals to R N minus 1, right? So R equals to small r, that is the final result. If sorry, if the resistance equals to internal resistance, if the resistance of the circuit is equals to the internal resistance, then ES will be equals to EP. Two wires A and B of the same, next question, two wires of A and B of the same metal having radius ratio 1:2 and carry the currents in the ratio of 4:1, the ratio of the speed of the electron. Okay, I equals to any VDA. This is the form. This is the dip velocity formula. I equals to any VDA, right? Now the radius are in the ratio R1 by R2 equals to 1 by 2, and the currents I1 by I2 equals to 4 by 1, right? And by 2 equals to 4 by 1. Okay. Now we can say 4 by I equals to any VD pi L square and pi 1 square, and any VD pi into 2 square, right? First one is 1, second one is 2. So that therefore that the relation between the ratio between dip velocity will be equals to 4 into 4 by 1, that is equals to 16, right? The resistance of a wire at room temperature 30 degrees Celsius is found to be 10 ohm. Apply this formula, temperature coefficient. The temperature of the wire must be the temperature coefficient. You have to calculate now to increase the resistance by 10%. That means at first the resistance was 10, it means the final resistance would be 11. Okay, 10% means 11. Okay, now if you initially it was this RT equals to R naught 1 plus alpha T. Alpha is given as 0.002. We will put the value later. And alpha is T temperature is 30, right? So that means this will be equals to this. And for the finally, as I told you, the final distance will be 11. So R naught equals to 1 plus alpha T, 11 alpha. If we, this is our number 1 equation, this is a number 2 equation. If we divide number 2 by number 1, okay, you will get this. And if you solve this, you will get that T is equals to this will be equals to 1.6 divided by 0.02. This is equal to 83 degrees Celsius. Means option 2 is correct. Okay. Now for the 11, each of the resistance in the network, this figure is equal to R. The resistance become the terminal A and B. Okay, this one A and B. This is a Western bridge connection. If we rearrange this, it will look like this Western bridge. This will look like a Western bridge, right? In Western bridge, we know that no current passes through this galvanometer, right? This middle resistance. Therefore, this by this equals to this by this. E by Q equals to R by S. No current will flow through the KL, right? And means the middle resistance. Okay. The equivalent resistance in the AKM. What is AKM? This AKM. This is A. This is K. This is M. This path. R plus R. These two are in series, and these two are also in series. R plus R. This is 2R. This is also 2R. Right? So therefore, the final resistance, these two are in parallel, right? That means Rp equals to multiplication of the resistances, uh, multiplication of the resistances divided by the addition of these two resistances, right? That means R square by 4R, 4R cancel out. That means R means the our uh, equivalent resistance at A and B terminal is equals to R, right? Okay. 3-volt battery with a negligible internal resistance, small r is 0 here or neglected here, is connected in a circuit as shown in the figure. Okay, like this. A triangle is connected to a rectangle. Okay, if you rearrange this, this will look like this. 30 ohm, 3 ohm and 3 ohm, these two are in series, and with this is in the parallel. Okay, it means 3, 3, 6, 6 and 3. These two are in, means if these two are in parallel now, 6 and 3, that means equals to 6 into 3 divided by 6 plus 3, which will be equals to 2. Okay, so the equivalent resistance is equals to 2 and the voltage is given as V. So from Ohm's law, I think we will get V equals to IR, I equals to V by R equals to 1.5 ampere, right? The current will be equals to 1.5 ampere. That is option number 2. Okay, next one, question number 30. It is also a AR question. Assertion is said, in assertion it is said, Kirchhoff's junction rule can be applied to a junction several lines but point in a line. No. Reason, when steady current is flowing, there is no accumulation of charges at any junction or at any point in a line. Okay. Kirchhoff's law, Kirchhoff's junction rule, that is the first one, right? Kirchhoff's junction law, this one. Total inward current equals to total outward current, right? Total inward current equals to total outward current, right? Kirchhoff's first law deals with the conservation of the charge of energy, as we all know that U will remain constant. That is, it is said in the just first law, right? Kirchhoff's junction rule. When the steady current is flowing, there is no accumulation of charge at any junction or at any point, as the charge is constant and the law of conservation of energy is maintained. So therefore, assertion is correct. Reason is also the correct explanation of the assertion. Question number 14, right? It looks like a Western bridge connection. You have to calculate I. V is given. You have to calculate equivalent resistance, right? So I think these two resistance were in these two were in series connection, therefore, and now they are in parallel connection. So the equivalent RP is calculated by the product divided by the addition. So you will get the equivalent R resistance is 10 ohm. So therefore, you can say I is equals to, from Ohm's law. This is from Ohm's law, right? This is from Ohm's law. Right? You will get this. The value of I is 0.5 ampere or a half ampere. So the option number 2 is correct. Question number 15. Now moving on to the question number 15. The wires are situated at the same distance. Current of 1 ampere, 2 ampere, 3 ampere flows through these wires in the same direction, both in the downward direction. What is the ratio of F1 to F2, where F1 is the force on 1 and F2 is the force on 2? Okay. First of all, this the pictures looks like this one, this one. Okay, this is 1 ampere, 2 ampere, and 3 ampere. We have to calculate the force acting on this one and force acting on this one, and then calculate the ratio of F1 and F2. As we all know, for a magnetic, if force on a magnetic force on current carrying the in magnetic field given by this formula, it is the force per unit length. Okay, not the actual one, force per unit length. As the in the first wire, the force will be developed by this wire and also by this wire, right? So therefore, the total force on the number one or the for the first wire will be due to the second wire and this is due to the third wire. If we put the values, okay, of the values of current, like I1 equals to, here I1 equals to 1 ampere, I2 equals to 2 ampere and I3 equals to 3 ampere. Okay, if we put the values here, we will get F1 equals to 7 mu naught divided by 4 pi d, right? Similarly, if you calculate the value of, if you calculate the force acting on the second wire by it is applied by the first wire and the third wire, right? You will get that the force applied on the second wire is equal, F2 equals to this. And if you just take the ratio, you will get this. This one cancel out, this one cancel out, this one cancel out, this one cancel out, 4 cancel out, 4, right? 4 to the 8, right? I think. Yeah, 4 to the 8. 7 by 8 will be the answer. Option number 1. Okay, moving on to the next question. The two straight long wire AOB and COD are perpendicular to each other like this. And COD are perpendicular to each other. Okay, this one. Perpendicular to each other, carry currents 1 and 2. The magnitude of the magnetic induction at a point P at a distance A from the point O. Okay, in a direction perpendicular to the plane of ABCD. In this direction. Okay. Okay. Now what you have to calculate? You have to calculate the magnetic induction. To calculate the magnetic induction, right? A point P is lying symmetrically with respect to the two straight long wires, because from here the distance and from here the distance is equal, right? The magnetic fields P due to those current carrying conductors are mutually perpendicular to each other, right? These are two perpendicular to each other. Okay, so therefore, if we calculate the magnetic induction, you will get this mu naught equals to mu naught by 2 pi into A into I1 plus I1 square plus I2 square whole square. Okay. Now moving on to the next question. A uniform electric field and a uniform magnetic field are acting along the same direction, a certain region. If an electron is projected in the region such that its velocity is pointed along the direction of the fields, then the electron. Okay. That is the okay. So magnetic force F equals to, formula is given by QVB, Q V cross B, right? This is the formula QVB sin theta. Okay. Now if an electron is projected in the region such that its velocity is pointed along the direction, then the electron V and B are in the same direction, so that the magnetic force on the electron becomes 0. If this VB sin theta, this is VB sin theta, right? If the theta becomes 0, that means F will also become 0 from this formula, F equals to QVB sin theta, right? So if the velocity is acting in this direction, then the force should act in this direction, so that there is no movement of the electron in the certain direction, right? So we'll turn towards I think the option number 2, speed will decrease as the force is acting on the opposite direction. Plus it will come at rest. Okay, question number 18. The coil 1 turn is made of wire of certain length, and the from same length coil of 2 turn is made. If the same current is passed to the both cases, then the ratio of the magnetic inductions. Okay, magnetic induction formula is already discussed. Okay, so first there is a coil. Coil means circular in nature. You have to calculate, first you have to calculate the perimeter, that is given by the empire, right? So that means the radius of the coil, this one, will be equals to L by 2a, 2 pi, sorry, 2 pi. Okay, and magnetic field formula mu naught by 4 pi, mu naught by 2 pi r. Okay, for a circular magnetic field at the center is given by the formula mu naught by mu naught I by 2 pi r. Okay. So in place of r, if we put the value, we will get b equals to mu naught I by l. In the second case, the r dash equals to l by 4 pi, right? So if you put the value here, right, if you put the value here, you will get this 2 mu naught I by l by 2, right? If you put the value here, l by 4 pi, you will get the value, you will get this value. Okay. Now putting the value of b. Now if you put the value of b in the b dash equation, we'll get that b dash equals to 4b, or you simply you take the ratio, right? You will get this. This will be equals to 4. It means b dash equals to 4b. Okay. Now question number. This is from the optics, I think, ray optics. The following figure shows the reaction refraction of light at an interface. Three media correct the order of the optimal density of the media of. Okay, you have to, like, what you have to do, you have to just compare the density of the media. Okay. As in the case, and from the first surface to the second surface, right, from the first plane to the second plane, the ray is moving towards the ray is moving ray is moving towards the normal. That means whenever the light ray passes from rarer to denser, like rarer to denser, then the light ray comes towards the normal, and whenever it moves from denser to rarer, therefore in that case it moves away from the normal. It's away from the normal, and it towards the normal, right? It is away from the normal and towards the normal. As you can see in the figure, whenever the light ray is passing from 1 to 2, right, passing from this one to this one, medium 1 to medium 2, you can say that it is moving towards the normal. That means medium 1 is the rarer medium and medium 2 is a denser medium, right? Yes. And in the second case, the ray is also moving in the towards the normal. That means one is the denser medium, the medium 3 is also denser than medium 1, right? And medium 2 is denser than the medium 3, right? So you can say that the density of number one medium is lowest, density of the two is at the mid, and density of third medium is at the highest. Okay. A vessel of depth x is half filled with refraction index of mu, oil of refraction index of u. Other half is filled with water of refractive index mu z. The, the apparent depth of the vessel when it is viewed from as like this. This is the vessel. Okay, the image is already given. Okay. Refraction through different medium. Like, yeah, this is the, as we know, that refracting index is nothing but real depth by apparent depth, d by d dash. Sometimes it is written like this. This is the d by mu, right? Apparent depth when it is viewed from above. Approximate d, or the d dash, will be equals to, like, see this. This is a this is the water. This is an oil, right? If you watch from this, right, the light passes through this medium and this medium too. So therefore, you have to take into account this medium and also this medium, right? So therefore, d for d dash for the water will be equals to d by or x by mu, and for the other one is also x by mu, right? So therefore, I think for the total change in the depth will be equals to the depth change for water, then the depth change for oil, right? So you can say that from this equation, x by 2 equals to 1 by mu 1 plus mu 2, and if you solve this, you will get mu 1 by mu 2 at the denominator, 2 into mu 1 mu 2, and at the here you will get x mu 2 plus x mu 1. Okay. So this will be our correct answer. So therefore, I think option number 1 is correct. This one from the lens chapter. It's an thin convex lens made up of from round glass. 3 by 2 has round glass whose refractive index is 3 by 2 as focal length of f. Okay, when it is measured in two different liquids having refractive index 4 by 3 and 5 by 3, it has the focal length f1 and f. Okay, the correct relation between the focal lengths. Okay, as we all know, if a lens is dipped into a denser medium, uh, f the f gets lower, right? F decreases. From the lens maker's formula, this is the lens maker formula for convex lens. 1 by f equals to mu by mu l minus I 2 by r. Right. Putting the values, we can calculate the focal length for two situations. In one, I think you will get it is written 4r, and another one will get 5r. Right. If you put the values in this equation, like 3 by 2, 4 by 3, and 5 by 3, you will get the value. Right. You will get the value. In one case, you will get 4r, another case, you will get 5r. So therefore, I think Hmm. This 4 and minus 5 so that means one of them is becomes negative, and f1 yeah, that is greater than uh, the refracting index of the that is focal length of the object when it is in air. Okay. Okay, moving on to the next question. Question number 22. When an unpolarized light incident on the plane glass plate at Brewster's angle, right? That means theta. Then which of the following statement is true? At Brewster's angle, only the is reflected light is plane polarized, but the transmitted light is partially polarized. Right? This is according to Brewster's law. That means the reflected ray, the ray that is reflected is polarized, but the ray that is transmitted, but it is not polarized, fully polarized. It is partly polarized. That means option 3 is correct. Another AR question. In YDAC young double slit experiment, I1 equals to 9 I naught, I2 equals to 4 I naught, I max by I min equals to 25. This is the classic formula, right? Question number 23. In YDAC, reason is given I max equals to root over I1 square plus root over I2 square. It is correct. And I min equals to I1 minus root over I1 minus I2. This will be minus, I think. I min is given by the formula root over I max plus root over I min and whole square of this. This is the I1 minus I2 whole square. This is the formula. Okay. This is the YDAC. In case of YDAC, that means I think YDAC I not equals to I2 equals to I max by I min. Oh no, this will not be 25. That means assertion is correct, but the reason is not correct because I minimum and I maximum both are given same. As I told you, I minimum is I root over of I1 minus root over of I2 whole square. But here I minimum is given root over I1 plus root over I2. So therefore, assertion is correct, but the reason is not the correct explanation of the assertion. Right? 24. In the Young's double slit experiment using monochromatic light of wavelength, the path difference corresponding to any point, wavelength lambda, I think the wavelength is lambda, corresponding to any point having the half peak intensity is intensity I is given by this formula I naught equals to cos square phi by 2. Phi is the phase difference, right? Okay, it is said that the corresponding to any half of the peak intensity given by the I naught. So here the peak intensity will be half, that means I naught by 2, right? So in place of in this formula, in place of I put I naught by 2, Therefore, you will get cos square phi by 2, phi equals to pi by 2 to n plus 1, right? As we all know, the phase difference equals to lambda by 2 pi into path difference, right? So if you put the value in this formula, right, the path difference, value of phase difference in this formula, you will get the path difference, right? So therefore option 1, 2 is correct. Okay, and question number 25. Parallel beam of monochromatic light on polarized light is incident on a corresponding dielectric plate of refractive index on by root 3. Okay. The reflected beam is completely polarized. Okay. This has to be done by Brewster formula. Tan theta equals to tan IP, right? Tan IP. So IP is the polarized angle. Tan IP equals to 1 by root 3. That means IP will be equals to 30 degree. Sorry, root 3 is 60 degree. It will be equals to 30 degree. I mean, option 1 is correct. I think option 1 is correct. Okay, another AR question. Assertion is in the process of photoelectric emission. In the process of photoelectric emission, all emitted electrons do not have the same kinetic energy. Okay. Reason: if radiation falling on photosensitive surface of a metal consists of different wavelengths, then energy acquired by electron absorbing the protons of different wavelengths shall be different. Okay. This is photoelectric emission. This is from photoelectric emission, right? These two statements are individually true, right? Because in the first one, as in the assertion, it has been said that in process of photoelectric emission, all emitted electrons have not, they don't have the same kinetic energy. Yes, they do not have the same kinetic energy. Someone is greater, someone is lesser, right? If and some ray comes to a surface, metallic surface, there will be emission of electron. Okay, there will be emission of electron, but they will not have they will not have different energy. They will have the same energy. That is equals to Emax, right? That is equals to Emax, right? Which is equals to sorry, H nu equals to Emax plus W naught. W naught is the work function, or sometimes the okay. That means these two are correct, but uh, assertion is correct, but the reason is not the correct explanation of the assertion. Okay. Okay. I'm moving on to the next question. Two radiation of photon energies 1 electron volt and 2.5 electron volt successively illuminate photosynthesis metallic surface of work function 0.5. In both the cases, W is 0.5. So put this formula: H nu equals to Emax plus W naught. Okay, that means Emax in first case is 1 electron volt. In 1 electron volt, another one is 2.5 electron volt. Right? The ratio of the maximum speeds emitted. Okay, as we all know, Emax equals to H nu minus W naught. H nu equals to the energy of the photon, right? That means in place of, you can put this formula half mv square, right? That is the formula to calculate the kinetic energy of the electron. And E is given 1 electron volt, and this one is given as 0. Work function is given as 0.5. That is 0.5, right? And the mass of electron v square equals to in place of, if you calculate this, this will be equals to v square equals to 0.1 by m, and v2 square equals to v2 square equals to 4m. So v1 square by v2 square will be equals to 1 by 4. It means v1 by v2 equals to 1 by 2. right? So therefore the ratio 1 by 2 is correct. Number 2, the work function of silver and sodium. Work function of silver and sodium is W equals to 4.6 and 2.3 electron volt respectively. The ratio of the slope of the stopping potential versus frequency plot for silver to that of the sodium is okay. This is the graphical representation, right? The graphical representation. This is the slope. This one is the slope, right? This one is the slope. How to calculate the slope? Slope is given by the formula h by E, but h is the Planck's constant and E is the electron. So therefore, the ratio in both the cases you can see that the slope doesn't depend on the work function or any other thing. It depends on the Planck's constant and E, and these two are both are constants. Thus, they have this constant value. So therefore, if we take tan theta in both the cases for sodium and silver, so in both the cases the value will be equal. So therefore, the ratio will be 1:1 or 1. Okay, moving on to the next question. When an impurity is doped into an intrinsic semiconductor, the conductivity of the semiconductor. Okay, first of all, what is a what is an intrinsic semiconductor? Or how it is doped? Right? When the semiconductor is doped, right, the number of charge carriers or electrons or holes, whatever, this increases. So therefore, the conductivity increases. Right? The doping is that the main purpose of doping is to increase the mobility of the charges, right, and also the increase the charge density in the semiconductor. So therefore, I think as the number of charge increases, conductivity also increases, right? So therefore, option 1 will be correct. Question number 30. By increasing the temperature, the specific resistance of the conductor and the semiconductor. Okay, these some conductors are known as ohmic conductors, and semiconductors they are known as non-ohmic conductors. R is proportional to rho, right? For all the conductors, semiconductors, and insulators out there. No, ohmic conductors. In case of ohmic conductor, as the temperature increases, resistance also increases. But in case of the non-ohmic conductors like the semiconductors, as the temperature increases, the resistance decreases. Okay, so option number 3, specific resistance of the conductor increases and for the semiconductor it decreases. This is by explained by the ohmic and non-ohmic conductors. Following the diagram performs a logic function. Okay, 2 gates are given. Okay, so the the output here is x equals to AB, bar of AB, right? And y equals to x bar, that is AB bar, that is equals to AB, right? So therefore, the diagram is a what kind of gate? So the diagram is a AND gate. X equals to AB, multiplication of. Okay, the truth table is given for the this logic gate. Uh, 4 NAND gates are there. You want to have, yeah, 4 NAND gates are there. You have to predict which one is the logic gate out of these options, of the following options, right? So here for the NAND gate, the output is equals to AB bar, right? So finally, the final will be equals to finally this one will be the final output. Okay, A AB and B AB. Okay, so by if we simplify it, you will get this AB plus BA, right? So therefore, I think option 1 is correct. 0 0 0 0 1 1 1 0 1 1 1 0. right? So option 1 is correct. 33. Assertion: a p-type semiconductor is a positive type crystal. P-type semiconductor is an uncharged crystal. Uh, First of all, understand this. The p-type conductors are the conductors which has the majority of charge, that is transported by the positive holes. So these are known as the p-type conductors. The minority is the electron and the majority is the positive holes, right? Okay. So so there is no mention of whether a semiconductor will be can be a p-type semiconductor can be a positive crystal or a p-type conductor can be an uncharged crystal. So I think assertion and reason both are wrong. Okay. Question number 34. Question number 34. When the forward bias voltage of a diode is changed from 0.6 to 0.7, the current changes from this. Then the forward, calculate the bias resistance like Ohm's law, V equals to IR, right? R equals to V by I, the change in V divided by the change in I, del I. So the change in V is 0.1 volt, and the change in current is 10 milliampere. Okay, so if you calculate, this is 1 by 10, this is 10 milliampere means 10 to the power minus 2 ampere, right? So therefore, if this will be 100 by 10, that means equals to 10 ohm. This is the resistance. Okay, moving on to the next question. The ratio of the concentration of the electrons to the holes in a semiconductor is 7 by 5. The ratio of the current is 7 by 4. What is the ratio of the dip velocity? That formula is I equals to NE VDA, right? So there is the relation between the dip velocity and the current flowing. The VD's, the relation between VD and I is directly proportional. That means I1 by I2 equals to VD1 by VD2, right? I1 by I2 is equals to 7 by 5, 7 by 4. That means 5 by 4. VD1 equals to, oh, you have to calculate just the ratio. That means this one is the ratio. 5 V1 by V2 equals to 5 by 4. That means option number 3 is correct. In the circuit, next question, in the circuit given below, the charge in is microcoulomb. Okay, the capacitor having capacitance 5 microfarad. EMF is given as 6 volt, right? EMF, the total potential is given as 6 volt. The capacitance in the branch, we know the formula that Q equals to CV, right? Q equals to CV, right? So voltage is given as 6 volt, and if you calculate the equivalent capacitance, it will be 2.1, right? How? 5 ohm, 5 farad and 2 farad, these are in parallel, so therefore the equivalent resistance will be 7. 7 and 3, that means these two are in series, that means 7 by 3 plus 7.1, that is equals to 2.1 farad, 2.1 microcoulomb, right? 2.1 microcoulomb. So here 2.1 microcoulomb, sorry, microfarad, that is the capacitance, microfarad here, right? Now this is the total charge on the circuit, right? 12.6 microcoulomb. So along the charge that is so the voltage in the 3 microfarad. How to calculate voltage in the 3 microfarad? Just divide the total charge flow by the capacitor, you will get it. Q equals to CV by this formula. Okay, Q by C. Q is equal to 12.5, C is equals to 3. and in this connection, these two are in parallel, right? The potential will be equals to as the total potential is 6, so the potential here will be equals to the remaining portion, that is 6 minus 4.2, that will be equals to 1.8 volt, and the passing and the charge passing through it will be equals to C into V. C here is 5 microfarad, and the charge passing through is potential is equals to 1.8. Therefore, you will get the value of charge is 9. Okay. ABC is equilateral triangle, charges plus Q are at the each corner edge at its vertices as shown in the figure. The electric intensity at center O will be. Okay, you have to calculate the electric intensity C at O. First, see this picture. The distance is in all the direction. Distance is equal, right? So therefore, as we all know, charge is equal, right? So we all know that F is proportional to 1 by R square. If the R is equal, then the force applied by these three will be nullified by each other. Therefore, no amount of force will be remaining. Net force will be 0, right? So the option 4 is correct here. An electric charge of 10 to the power minus 3 microcoulomb is placed at the origin of, like this, 38. This is question number 38, right? Like this. Here, a charge is placed 10 to the power minus 3 microcoulomb, right? Here, 2 points A and B are situated at 2.2, 2,0 respectively. Potential difference between these 2 points. This is 2.0, right? So this is this, and this is this 2.2. So the potential difference between the distance will be equals to root over 2 square plus 2 square means 4 plus 4, 2 root 2. The answer distance will be 2 root 2, right? This one distance will be 2 root 2. Okay, root 2 square and root 2 square. Okay, I think it will be root 2 and root 2. Sorry, there is root 2 and root 2, not 2 and 2, root 2 and root 2. Mentioned question it is not mentioned. Okay, A is root 2 and root 2, so there is distance, this is the distance. How to calculate this portion is 2, this is root 2, therefore root 2 square means 2 square plus 2 in 4, that means equals to 2 unit, right? This is the distance, distance from origin. Okay, now I have to calculate this distance. How to calculate it? First, because this is 0, right? So this will be equals to root over 2 square in 4, equals to 2 units. Okay, now if to calculate the formula, calculation is given by the formula 1 by 4 pi epsilon naught Q by R, right? R, sometime it is for this R will be 1 for OA, and for this chart it will be equals to OB, right? In both the cases R is equal to 2, right? In both the cases. So therefore the net potential will be always equals to 0. Okay, next, in a YDAC, right? S1, S2 are the coherent sources, and S is the screen through which the hole is placed, right? At a point 1.0 meter away from the central line. Okay, that means this 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 is 1 meter, 1 millimeter, right? This is also 1 millimeter, that is 2D. 2D equals to 2 millimeter. A white light of 400 to 700 nanometer is passing through the slit. Which wavelength passing through the hole has the strongest intensity? Okay, so this is from IDAC chapter, right? Wavelength interference chapter, right? So wavelength with maxima obtain the hole as the maximum intensity, right? The formula is n lambda d divided by 2d. Sometimes d and sometimes d is the total distance. 2d is the total distance. D is the, okay. So that means lambda equals to xd by nd. Putting the values of x, d, and d, right? It's all these all are given, right? You will get that the lambda value of is 1000 nanometer per. Yeah, for if the value of n is 1 and the wavelength is 1000 nm, not available in options, n equals to 2, wavelength is 500. So which is available? So that means 500 is the correct choice. Okay, 500 is the correct choice. This option number 3 is correct. This is a trial and error method, right? Sometimes you have to put a 1, 2, you have to see which answer is given, right? A ray of uh, ray of X, ray of light passes through four transparent media written in indexes mu1, mu2, mu3, mu4, shown in the figure 9. Okay, the surfaces of all the medium are parallel if emergent ray CD parallel to the emergent ray AB. No, that means the emergent ray and the incident ray are parallel to each other. That means no deviation occurs. Zero deviation. That means delta equals to zero. Zero deviation occurs. Okay. Now, as we all know, if in the refraction, if a ray passes through one medium to another medium, it tends to go towards the normal or away from the normal. It depends on the media, right? Depends on the density of the media, whether it is rarer or denser, right? But if no reflection occurs or no deviation occurs, that means here the first medium and the second medium, which is the light is traveling from. Okay, these two mediums are same medium, right? So this by then and then no deviation can occur. Okay, so therefore you can say option number, I think 4, mu1 equals to mu2. This is correct. Okay, question number 41. A glass prism of refractive index 1.5, mu is equals to 1.5. Mu equals to 1.5, immersed in water, refractive is 1.33, right? Glass mu g 1.5, mu w 1.33. The light beam incident normally on the face of AB, totally reflected to each on the face of BC if. Okay, this is AB and this is BC. This is BC. So incidenting on this plane and out of this plane, right? So therefore we can say the this G, that means the refracting index of the, or whenever the light passing through from a glass to the water will be equals to 1.1, that means 5, um, 1.5 divided by 4.5 divided by 4, that means equals to 1.125. Yeah, it's corrected. Okay, if the value is put, if you put the value in this, that we all know that mu critical equals to 1 by sine theta c, right? Mu equals to 1 by sine theta c, so sine theta c will be equals to 1 by mu. The value of mu is 1.125, that is 1 by 125, 8 by 9. That means sine theta, the value of sine theta is equals to 8.9. So therefore you can say the option 1 is correct, almost greater than equals to. Okay. Question number 42. A wire has a resistance of 12 ohm. It is bent in the way from a circle. The effective resistance between 2 points of the diameter. Take like this. This one. You have to calculate the resistance if in from this point to this point. As you all know, this the resistance of the wire was capital 112 ohm, right? Uh, the effective resistance between 2 points and, okay, to form a circle. Okay, the equivalent resistance between 2 points on the diameter. And if we consider the diameter, it will become a half circle or semicircle, right? So here the resistance will become, as the length becomes half, resistance will also be half. Now, if we add other part of the circle or the sphere, you will get the 6 ohm here also. So these two are in parallel, right? So you have to calculate the RP. RP is equals to multiplication by addition. That means 36 by 12. That is equals to 3 ohm, right? 3 ohm. That means option number 2 is correct. A battery of EMF 10 volt and internal resistance R, small r, is given, connected across a variable resistance capital R. the value of R for which the power delivered in its maximum will be. Okay. Power in the circuit will be maximum if the value of the external conduction band, but the sorry, as we proved in the early, I think fourth numerical, if R is equals to smaller, then I will be maximum. As I will be maximum, I all know that P equals to IV. If the I is maximum, therefore the power will be also maximum, right? So therefore you can say if the value of R is equals to 0.5, then it will deliver the maximum power. Okay. Question number 44. It is a conducting circular loop of radius smaller, carries a constant current. It is placed in the uniform magnetic field B such that the B is perpendicular to the plane of the loop. The magnetic force acting on the loop, right? So you have to calculate the magnetic force acting on the. So in the force acting on a closed loop due to the uniform magnetic field, perpendicular perpendicular to the loop is always zero. As I told you, always the cos theta component, if the theta is equals to 90 degree, therefore the force will always be equals to 0, right? However, if the magnetic field changes from time to time, or close not a closed loop, the same net force acting on the under. If some if it is not closed, thus there is certain amount of force will be acting on the object, right? Acting on the coil. Okay. Therefore, option 3 is correct. As it is told that in the question, it has been told that the magnetic force acting on the if the uh, if the magnetic field such that the B is perpendicular to the plane. The magnetic field is perpendicular to the plane, so therefore no force will occur. So 0, the value amount of force will be equals to 0. The work function W is 40 electron volt, the longest wavelength of the light that can cause electron emission from the substance. Okay, uh, we all know that W is equals to H nu naught, where nu naught is the threshold frequency, right? So W equals to Hc by lambda naught. So lambda naught will be equals to Hc by W, right? From this formula you have to calculate H 6.67. Okay, if you put all the values 10 to the power minus 34 and C 3 10 to the power 8 and W is equals to 4, you will get the value of 310 nanometer. That means 310 into 10 to the power minus 9 meter. Okay, this will be the value. Okay, here logic gate is given. Uh, just solve it by a Boolean algebra, right? This one and this one. This is A bar, B bar, right? A bar, B bar, and this is also A bar, B bar, A bar into B bar by of A B bar, right? So you will get this A plus B bar, the bar of A plus B, bar of A plus B, which will be equals to A plus B. That is the formula of OR gate. AND gate is and multiplied in AND gate, and in OR gate it is been added. Okay. In a VI characteristic graph, the PN junction reverse biasing result in. Okay. Bias and for the is a semiconductor formula. Okay. If the PN junction is reverse biased, okay, there will be a generation of Jenner breakdown. Okay, so therefore there will be a leakage of current flow, right? Okay. Question number 14. In a semiconductor at room temperature, semiconductor semiconductor the conduction band theorem in case of conductor right, it is overlap, but in case of semiconductor, like the value of the Eg is lesser than 3 electron volt, right? Lesser than 3 electron volt. The options are given. And semiconductor at room temperature, the conduction band is completely empty. No, the vehicle the sorry the valence band is partially empty and the conduction band is partially filled. Okay, the valence band is completely filled and the conduction band is partially filled. Okay, the valence band is completely filled. The from the semiconductor concept, we can say that the electrons, which if they absorb certain amount of energy, they will go to the they will go from uh, lower energy level to higher energy level, as we all know that. Okay, at the room temperature, some of this electron gain the little part of energy to undergo excitation from the valence band to the conduction band, right? So therefore, we can say, but the other electron remains in the valence band. So we can say that some of them are in the valence band, the partially empty, the conduction band is partially filled, right? So sum of electron goes from um, valence band to conduction band. So therefore, there is a lack of electron here, and there is a number of electron that is rising in the conduction band, so that it can generate or transport electricity. Right? A ray of light is incident normally on the one refractive surface of an equilateral prism. If the refractive index of the material prism is 1.5, refractive index is 1.5, right? We all know that if the critical angle mu equals to 1 by sine theta c. This is the critical angle, right? This is from total internal reflection theory. Mu sine, that the value is given as 1.5, right? 3 by 2, 2 by 3. Sine theta c equals to 2 by 3. Okay, now a ray of light is incident normally on the equilateral prism if the refractive index on material is 1. Okay, the emergent radius deviate. Okay, now let us take a condition where if we put the value of theta c of the critical angle is 60 degree, then it will be equals to 2. The value of mu will be equals to 2 by root 3, right? Uh, but in our case, it is given 2 by 3, right? So sin theta c will be equals to 2 by 3, right? Sin theta c will be equals to 2 by 3. So c equals to sin inverse 2 by 3, that is equals to around 42 degree, which is lesser than 45 degree. So therefore, critical angle is lesser than the angle of incidence. This is the angle of incidence. This is the critical angle, which is lesser than the critical angle is lesser than the angle of incidence, because the critical angle was 60 degree. Last question: a prism of refracting angle 60 degree when it's placed in the position of minimum deviation. Minimum deviation condition is this: the minimum deviation condition, of 30 degree delta. Delta is given 30 degree, and the angle of prism is 60 degree, right? So you have to calculate the angle of incidence. Angle of incidence equals to the average of these two, 30 degree plus 60 degree, that means by 2 equals to 45 degree. Answer 2 is correct. Okay, the paper is finished. Best of luck for your next paper.